Hello everyone, welcome to this lecture. In last lecture, we obtained unit vectors in cylindrical coordinate system. Those unit vectors were E rho cap is equal to cos of phi I cap plus sin of phi j cap, then E phi cap, it was minus sin of phi I cap plus cos of phi j cap, and then Ez cap is equal to k cap. So these unit vectors are in cylindrical coordinate systems, and I cap, j cap, k cap are unit vectors in Cartesian coordinate system. So what we see here, that we have expressed unit vectors in cylindrical coordinate system in terms of ijk, that is unit vectors in Cartesian coordinate system. Now in this lecture we are going to obtain I, j and k in terms of E rho cap, E phi cap and Ez cap. Okay, so we will begin with this. What I will do, I will name these equations or number this equation. Equation 1, this is equation 1, and this is equation 2, and this is equation 3. Okay, so first I will work out for I. What I see, that equation 1 and equation 2 contains I, and there is one factor with I, that is here it is cos of phi, here it is sin of phi. So I will do a simple thing. I will multiply equation 1 by sin of phi, as it does not contain sin of phi here in I term, and I will multiply equation 2 by cos of phi. So they will look like, if I multiply this whole equation by sin of phi, then it will be sin of phi. I am multiplying equation 1. So E rho cap, sin of phi, E rho cap is equal to sin of phi, this sin of phi, then cos of phi I cap, then there is a plus sin of phi, it is sin square phi j cap. Now I am going to multiply equation 2 by cos of phi, so it will become cos of phi E phi cap is equal to cos of phi minus sin of phi. I will put this minus sign here, sin of phi I cap plus cos square phi, cos of phi into cos of phi, that will be cos square phi j cap. Now what I see is this: if I add these two equations, okay, this equation and this equation, I will get sin of phi E rho cap plus cos of phi E phi cap is equal to, what you see here, here is sin of phi cos of phi I cap minus cos of phi sin of phi I cap. Then this will get cancelled because this is a positive term, negative term with same components. And here you can see, if I add this will become sin square phi j cap plus cos square phi j cap. From here I can take j cap common, so it will look like this: sine square phi plus cos square phi, and I am taking j cap common. You know that here is a sine square phi plus cos square phi, that will be equal to 1. That is the identity, right? So this will be j cap. So what I have obtained is e rho cap plus cos of phi e phi cap, and this is expression for j cap. So you can see I have expressed here j cap in terms of e, this is e rho cap and e phi cap, right? And there is some sin phi term and cos phi term. Similarly, okay, actually in the beginning I thought I'm obtaining for I cap, but we are obtaining for j cap. So we will try to obtain for I cap now. So again we have to go to our first equations. What I saw that if there is a cos square term over here and there is sin square term here, right, and if I add them, so there is a negative sign, so if I subtract them, then this sign will become positive and I will get cos square plus sin square term, and there will be I cap. So we will do it here. Again, what I will do, multiply equation 1 by cos of phi and equation 2 by sin of phi. Why I am doing like this? I want to add those equations after this multiplication or subtract those depending on the situation, okay? And due to my this operation of adding or subtracting, I will get some other terms and some term will be vanishing after this addition. So let us see. Okay, we will go back. This is a cos phi and sin phi, okay? Then I'm multiplying it by cos of phi. So this will become cos of phi e rho cap is equal to cos square phi I cap plus cos of phi, this is cos of phi, and originally there is a sin of phi j cap. Similar thing I will do with equation 2, and equation 2 will become sin of phi e phi cap is equal to, negative sign is there, sin square phi I cap. What I am doing, I am multiplying equation 2 by sin of phi. I hope you can see it clearly. Okay, then sin of phi, and there is a second term is cos of phi. So sin of phi cos of phi j cap. Okay, if I add this equation, that is not going to give me useful thing. So what I will do, I will subtract this equation, okay, this equation from this equation. So this will be subtraction, negative. Now this negative will become positive, this positive will become negative, and you can see it will become like this: cos of phi e rho cap minus sin of phi e phi cap is equal to, so here you can see cos square phi. What I did here, I subtract this term from this term, that is cos of phi e rho cap minus, this minus sign is here, then sin of phi e phi cap is equal to, now I am going to add these two terms, that will be cos square phi from here I cap. Now this plus sign, okay, we are doing subtraction, that's why negative sign became positive, cos square I cap plus sin square phi, okay, I'm sorry, it is I cap, sin square phi I cap, this is I, and then you can see cos of phi sin of phi cos of phi j cap, so these are same term with different sign, and I am going to subtract them, so they will cancel. Now this is the final expression, but I can modify it by taking I cap common. So cos square phi plus sine square phi. Okay, again this is I cap, right? So I took this common, and okay, so you know this is 1, so it will be I cap only. So I got the expression for I cap, which is cos of phi e rho cap minus sine of phi e phi cap is equal to I cap. Now I want to obtain expression for, I obtain for I cap, I obtain for j cap, then I want to obtain for k cap. But what I see in equation 1 and equation 2, right? In equation 1 and in equation 2, I don't see there is a k cap. I only see k cap in equation 3, and this is very simple. You can, as you can see here, Ez cap is equal to k cap. Then it implies that k cap is Ez cap. So this is the expression for k cap is equal to Ez cap. So in this video we obtain 3 expressions. First for I cap, which is I cap is a unit vector in Cartesian coordinate system. So I obtained the expression for I cap, which is cos of phi e rho cap, here you can see, minus sine of phi e phi cap. Then I obtained expression for j cap. Where is the j cap? Here is the j cap, you can see. So I am carrying it over here. Sine of phi e rho cap plus cos of phi e phi cap, and then expression for k cap, which is very simple, Ez cap. So in this lecture we have obtained these 3 expressions. Okay, so for today we will stop here. In next lecture we will deal with the cylindrical coordinate system, that is unit vectors in cylindrical coordinate system, and we will try to express them in terms of ijk, and we will do the vice versa. Okay, we will stop here. Thank you.